right, so we're back with the Algebra 2 January 2020 exam. I'm going to spend the next chunk of time working on the 2-point questions. So these are only worth 2 points. If you can get at least something down that's correct for each question, you're probably going to get a point. So it's very important for those of you who are just trying to pass, if you can do one thing at least for every question. Some of these are very doable. So let's see what we come up with. All right, the first one. For n and p greater than 0, we have this expression. Is it equivalent to this guy? Justify your answer. All right, so we're going to do this workout to see if it comes out to be that. All right. So everything in here is got to get that exponent. And when you raise a power to a power, you multiply. So 2 times 8 makes 16. So p is going to get to the 16 power. And we're going to do the same thing. 1/2 times 8 makes 4. All right, so the first piece here is this guy. And I'm going to put a time sign here to represent. So I'm going to, right, we're going to do that guy and that guy. Now, this is where we're going to do flower power. That's the square root. The square root means there's a little 2 in the corner. So we're going to do p to the 5/2 and n to the 4/2. So that's step 1. If you could do that, you're going to get a point. Okay? Now, the next part is to combine these. Okay? Now, when you're multiplying, you're going to add your exponents. So we're going to do those guys. And then n is going to do 4 plus, and I hope you realize that 4/2 is 2. Okay? So I'm going to put this part in my calculator. So I get p, I'm going to do 16. Click clear. 16 plus 5/2 makes 37/2. And 4 plus 2 makes 6. Okay. Now, notice we have n to the 6. So that matched. The question is, does this match? So let's do 37 divided by 2 and see what we get. 37 divided by 2 is 18.5. That means you're going to get p to the 18 and a p to the 1/2. That's literally what that means. So p to the 18 and a p to the 1/2 and 6. All right. And what does the 1/2 power mean, you guys? Well, the 1/2 power means the same thing as the square root. So is it equivalent? You would write, look at him, look at him. So you would say, yes, they are. And justify your answer. All this work is justifying your answer. So yes, they are equivalent. And that's the answer to that. So if you can do anything right, you'll get a point for that. You might not get all 2 points, but do I think you can get 1 point? Yes, I do. All right. Now, this one you should be able to get. Show why x minus 3 is a factor. So I'm going to do this 2 ways. All right. The first way, first method, is with synthetic division, right? So you're going to put 3 in a box, okay? And then you're going to do 1. Now make sure you're being careful there's nothing missing. If there's something missing, you have to put a 0, okay? Draw your line. The first number comes down. Whoop, first number comes down, but the first number is a 1. So let me fix that. 1. 1 times 3 is 3, add down. 3 times 2 is 6, add down. 3 times 1 is 3, add down. Remember, that's the remainder. Okay? So if the remainder is 0, it is a factor. Okay? Now, that's the first method. The second method is using what we call the remainder theorem, and that means whatever number was in the box, you just plug in for x. we're going to see what we end up with. Hey, 0. And whatever comes out is the remainder. So you do need a wrap-up sentence. Okay? So the wrap-up sentence is, since the remainder is 0, x minus 3 is a factor. Now that is a question I do think you guys can get both points on. That's a good one. Okay. This is a good one too. Okay. Describe the transformation. So the word transformation means how does it move? So describe how this guy moves compared to the original. So everybody see the x minus 3? If something is touching the x, you always go the opposite way. So even though it says -3, this means it shifts 3 to the right. So you get a point for that. And the number hanging off on the end moves it up or down, and you do exactly what it says. Shifts up 4. Boom, 2 points. 1 point for that one, 1 point for that one. That's all you got to do for that one. All right, next one, number 28. Where is number 28 hiding? There it is. Okay. The parabola has a focus at 3, 1. Determine and state the equation of the directrix. Okay, guys, anytime you get a question and they give you a point, let's plot that point. All right, so we're going to plot the point 3, 1. So here, we'll make an x and y axis here. Okay. Right? And the point 3, 1. 1, 2, 3, up 1. And that's the focus. All right. So I'm going to take this equation now. Just write it over here. Y equals -1 over 20. X minus 3 squared plus 6. So here's the deal. The vertex point we get from these numbers. It is always the opposite of the number in the parenthesis and the number hanging off on the end. So I'm going to graph 3, 6. So 1, 2, 3. 1, 2, 3, 4, 5. Here is the vertex. Now, parabolas have to eat the focus, right? Focus is food. So that means it's going to be a sad face parabola, which I also know from the negative out in front. Now, where does the directrix have to live? The directrix is the opposite side. So count 1, 2, 3, 4. It's 5 away. So that means we're going to go up 5. 1, 2, 3, 4, 5. And the directrix is a line, right, through 11. So the directrix is y equals 11, because that's where the line is. Now, I also want to point out to you, just so you guys see something here, this distance is 5. That's called the p. So sometimes they'll ask for the p. The equation of a parabola is 1 over 4p x minus 8 squared plus k. And what's 4 times 5? 20. That's where that 20 came from in the question. So there you go. So that's your parabola. All right, 29. Given the geometric series, so that means, again, geometric means we're multiplying. Okay, write a series formula, Sn. This comes right off our formula sheets. So you would go to the formula sheet on your test that we're going to have you guys rip out. Right? We did these the last couple days of school. Geometric series. That's literally what they're asking for. See the geometric series? So we're going to write this formula down. So it's Sn equals A1 minus A1 r to the n all over 1 minus r. Okay. Now, A1 just means the first number. So we're going to do 300 minus 300. 1 minus. Now, the R, now remember when I talked about a geometric earlier? We do the second number divided by the first number, right? So I'm going to do it over here. 360 divided by 300. I'm going to put that in my calculator. Alpha y equals 360 over 300 is 6 over 5. Okay? Now they're telling us it's geometric, but I'm going to do a second one just to test it, right? If I do alpha y equals 432 over 360, hey, see, that's the R. Right? All right, find the formula. So you get a point for that. And then use the formula to find 10. So we're now going to plug 10 in for n. So I'll write that down, right? Then we do alpha y equals 300 minus 300 parentheses 6 over 5 raised to the 10, 1 minus, 6 over 5. And it wants us to round to the nearest tenth. And that's our answer. Look at that. Okay. All right, 30. What the heck is 30 saying? You got these pictures. This one in your packet showed up really light, so I went over it with a pencil so I could see it better. Visible light can be represented by sinusoidal waves. So these are the sine curves. 3 waves are shown below. The midline is labeled, so that's the midline. Okay, based on the graph, which light wave has the longest period? So period is how long the curve takes. So it's the distance from high point to high point or low point to low point. But if you notice, like this graph doesn't have 2 high points, neither does this. So what I'm going to do instead is I'm going to do high point to low point and double it. So for A, okay, the high point looks like right here. There's the high point, which is at 60. And the low point is here at 340. Okay, so I counted them, right? I figured out where the high point was and the low point was. Okay, so let's do 340 minus 60. So let's figure out how far apart those are. It's 280, all right? And we're gonna do 2 times 280. So this is for A. I'm getting 560. All right, so that's the period. Okay, so now let's do B, the dash line. So here's B, so I'm going to put B here. So the high point is over 180. Here's the low point at 400. Okay, so I'm going to do 400 minus 180. 220. So now if I double that, it would be the period. Okay? So again, the period is how far it is from high point to high point or low point to low point, but this picture, they don't have both. So I'm doing the best I can here. So here, last one is C. Here's the low point also at 60. And there's a high point here at 380. So I'm going to do 380 minus 60. I'm getting 320. Okay. And then the period is just to double that, which would be 640. All right. So which one of these had the longest period? You would say C has the longest period. I thought this was a very tricky question. All right, so if you thought that was hard, I agree with you. That was a tricky question. All right, next one. So again, next one, as long as you can get a point or two, things are good. So let's see what it says. Biologists are studying a new bacterium. They create a culture with 100 of the bacteria and anticipate the number will double every 30 hours. Write an equation for B. All right, so B equals. Start with that. Always start with the original amount. The original amount is 100. Now, they're saying they didn't give us a percent. If it was a percent, you would say 1 plus the percent. But they said doubling. So you just put a 2 in there. Okay? And it's happening every 30 hours. The every means you divide. And that's the whole question. So if you could get at least the 2 in there, I believe you got a point. And that's it for number 31. Okay. And finally, number 32 is our last 2-pointer. Okay, and then we'll take a break, and then I'll do the 4-pointers and the 6-pointer. So next one, we want to graph this guy. Well, guys, we have a graphing calculator. So I'm going to go to y equals, clear out whatever's in there, and type that baby in there. X raised to the third. Okay, and then you do need work. The work is your table. Now, let's take a look at the graph they gave us, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes out to 10. All right, so 1, 2, 3, 4. So here's 5. 1, 2, 3, 4, 5. Here's -5. Right, here's 5. So it looks like it goes 10 in all directions. So we want to get as many points as we can in here. All right, so let's take a look at our table. I definitely can't graph -129, but it looks like I can do -1, 0. So I'm going to write that down. 0, 7. So you're writing down as many points as you can that you know you can graph. 3, 4, and 4, 15. I probably can't get them. So let's graph those. All right, I'm going to do it in green. So -1 is 0. Okay. 0 is 7. 1 is 6. 3 is, 2 is 3. 2, 1, 2, 3. 3 is 4. 1, 2, 3, 4. And 4 is 15, so it's going to be up here somewhere. Now, I do want to know what's going on over here, so that everybody would see at -2, it's at -21. So I do know at -2, it's down here. So basically, we want to come up from down there, connect the dots, and then we're going up. So we just want to put, and that's literally the whole thing. So that one, I think you could definitely get 2 points on. That's a good one. Use your table, all right? And you have to have arrows. Have to have arrows. So you do as many points as possible to create the picture. All right, gonna take another break here, and then we're gonna jump into the 4-pointers. All right, see you soon.